Dear students, in this session, let us discuss some properties of congruence. Let us take one property. If A is congruent to B mod M and C is congruent to D mod M, we need to prove that A plus C is congruent to B plus D mod M, A minus C is congruent to B minus D mod M, and third one is AC is congruent to BD mod M. Okay. Data is given. A is congruent to B mod M and C is congruent to D mod M. If A is congruent to B mod M, then M divides A minus B. If C is congruent to D mod M, then M divides C minus D. Observe carefully when the proof is given. Here there is a plus C is congruent to B plus D mod M. So I am going to add the equation 1 and 2. M divides A minus B, M divides C minus D, then M divides A minus B plus C minus D. Now I am going to grouping A and C because the proof is A plus C is congruent to B plus D mod M is there. So grouping the term, so A plus C, take minus outside, B plus D. If M divides A plus C minus B plus D, which implies A plus C is congruent to B plus D mod M. So hence proved the first one. For second one, observe A minus C is congruent to B minus D mod M is there. Let us subtract equation 1 and 2. Okay. Now take equation 1 and 2, subtraction. We get M divides A minus B minus of C minus D. Now open the bracket, A minus B minus C minus or minus plus D. Now grouping A minus C, take minus outside, we get B minus D. If M divides A minus C minus of B minus D, then AC is congruent to BD mod M. Hence proved the second one. Observe the third one is a product is there. AC is congruent to BD mod M. For this, for equation 1, I am going to multiply it by C. For second equation, I am going to multiply it by B. Now M divides A minus C in A minus B into C plus C minus D into B. This is for second equation multiplied by B. Simplify, opposite sign get cancelled with same quantity. Now AC minus BD. So which implies if M divides AC minus BD, then AC is congruent to BD mod M. Okay. Let us take one more the property. Another property. If A is congruent to B mod M and X is any integer, we can prove these three results. By data given A is congruent to B mod M, then M divides A minus B. If it divides, there exists a third integer, say K. I can take it as A minus B is equal to MK. Observe in the proof, there is A plus X congruent to B plus X. Okay, I am going to add and subtract X on LHS of the equation 1. Okay, now A plus X minus of B minus X is equal to MK. Simplify A plus X minus common outside B plus X is equal to MK. We can write this as M divides A plus X minus B plus X. If M divides A plus X minus B plus X, it can be written as A plus X is congruent to B plus X mod M. Hence proved 1. For second one, to prove that A minus X is congruent to B minus X, now I am going to subtract and add equation X on equation 1. We get A minus X minus of B plus X. Subtract and add. Now A minus X minus common outside B minus X MK. This relation can be written as M divides A minus X minus of B minus X. This can be written as A minus X is congruent to B minus X mod M. Hence proved the second one. The third one is AX is congruent to BX mod M. For this, I am going to multiply X on both sides of the equation 1. Okay. Now the equation 1 is A minus X is equal to MK. I am going to multiply X on both sides. Okay, you will get ax minus bx is equal to m kx. Since x is an integer here in the data, x is an integer. Okay, since x is an integer and k is another integer, the product of these two integers is another integer, say k1. Okay, so ax is minus bx is equal to mk1. This can be written as m divides ax minus bx. If m divides ax minus bx, ax is congruent to bx mod m. So hence proved the third one. Thank you.